Hi guys, in today's video we are going to focus on how we can simplify logs in N2. Right, so now before we dive into the log laws, there are three ways that we'll be focusing on simplifying the logs. So now on this video we're only focusing on the first approach, and then the other next two videos will focus on the other two approaches that you'd have to understand before you can approach any question on your exam or test or anyway. Right, now let's dive in. So let's look at the log laws. Right, these are the logarithmic laws that we must take into account when we are simplifying or solving any log term. Right, let's look at the first one. So now it's log a base x minus log b base x is equal to log a over b base x, and log a base x plus log b base x is equal to log ab over x. So now these two first laws are very important because some students make crucial mistakes when it comes to applying them. Right, now let's say for an example you have log 2 base x plus 3 log 2 base x. Now some students would say that this is equal to 3 log 2 over 2 base x. Now this is very incorrect, right? The correct way of representing this would be to say that it's log 4 2x. Now why? Because these are like terms, right? These are like terms, so we add or subtract like terms. We cannot apply these two laws if these are the same. These are like terms, so we can't apply the rule. So the only time that you can apply this law is if these two terms are different from each other. Now let's say for an example, now you have log 2x plus log 3x. You see the bases are the same, right? But now these aren't the same, so it means that our law applies. So we can say log it's 2 over 3. Now here this would be correct, but this would not be correct. So the first thing is you need to make sure that your bases are the same and that your two terms are the same. Then you can apply the law, right? So now let's look at the other one. If the base and term are the same, then it's equivalent to 1. If a log of 1, then it's equivalent to 0. Now log a base of log a raised to the power of n base a, it's equal to n log a base a, which is equal to n. Now this last law, it's very crucial because we will be focusing on it more than the other laws. Right, so now on this law, basically it's this law. So this law states that if you have a log term that's different from your base, you can divide them. So you can say log a is divided by log b. So now when it comes to this first approach, the way that they will ask you is the base, right, and the log term are so different from each other that you cannot convert your term to be in proportion with your base. Now what do I mean by this? Here's what I mean. Now for you to be able to simplify any log term, you need to have a base that's the same as your log term. Now this can be simplified, but if you have this 4 and 7, then you can't. Then it means that you must use this law. So this law is very crucial on this approach because we use it, right? So let's look at our question. Can this 187 be converted to its simplest prime factor, of which we will have um, a value approximately to the same as this 3. We can't, right? So now this means that we'll have to apply the law. 187 divided by log 3 minus exactly on this point, right? If you look closely at the log term and base, you can see that there's no way that we can convert the log to be in proportion with this. So the only way that we can simplify further is for us to divide them. So now this is log 3 divided by log 7 minus 1, right? Now from this point, as you can see, we have a negative power raised, right? So we need to remove that. For us to remove that, we need to apply an exponential law that says that if you have a over b raised to a negative power, you can invert the fraction. So this would mean that you would have b over a, then it's positive. So now this means that for us to have a positive bracket, we would have to invert this. So you have log 187 divided by 3 minus log 7 divided by log 3. See, now it's positive because we have inverted the fraction. Now from here the denominators are the same. Therefore, we have a lowest common division of log 3. So we have log 187 minus 7 divided by log 3, right? Now from this, as you can see, we do not have any base, so we need to introduce a base that would make our expression to be true, right, or real, so as to say. Now the only way that we can is to choose any value that we have already on our expression, so you do not have to think for a value or have to come up with a term that would make your expression correct. You just have to choose from these 3, right? So now let's look at 7. If we use 7, right, it may complicate our equation. If we use 183, then we are purely lost. So now the only one that we can use that may create our whole expression to be true and real, it's 3. So we can introduce base 3 on all of our log terms, right? If we introduce log 3, then it means we're getting rid of the fraction so that we can just simply focus on this. So we have log 3 187 minus log 3 7 divided by log 3 3, right? So now this is equivalent to 1. So now this means that we only left with log 3 187 minus log 7 3. Now from here, which law can we use? We can use the first law because these two are different from each other. So we can say that it's log 3187 divided by 7, which is log 3 1 over 27. Now from here we can say that it's log 3 1 over 3 cubed, right? Cubed. And then we need to remove this so that our log term is the same as our base, right? So now this would mean that we have log 3 negative 3. So now negative 3 log 3 3. This is equivalent to 1, so it's negative 3 1, which is negative 3. So that's basically what this approach focuses on. Your log term and your base aren't in proportion with each other, so we cannot simplify further. The only way that we can simplify further is for us to divide them. That's what this approach is focusing on. So now this is the first way that you may be asked either in your exam or test. Either way, you need to understand this approach. So stay tuned for more videos where we'll be doing the second approach and also when we do the last approach. Thank you for watching the video. Please do like and subscribe to my channel. to receive more videos. Thank you for watching.